Hi, I'm Igor. In this Getting Started tutorial, I will show you how to get started with pyFlies, how to install everything from scratch, and how to make your first Hello World example. So let's get started.
First thing to do is to install Visual Studio Code. Go to the Code website and download the package for your platform. All major platforms are supported. Since this is a getting started tutorial and the purpose of this tutorial is to install everything and to build a minimal Hello World example just to see how things works, I will here make a Hello folder, and then I will call code. I'll start code in the Hello folder, but I will instruct code to also search for extensions in this, or to store extensions in this code extensions folder, which is empty at the moment, because I want to show you how to install everything from scratch, so I don't want any extension at the beginning. So this is Visual Studio Code running, and we are in a Hello folder. First thing to do is to go to this tab. This is extensions tab, where you can see all the extensions available from the Visual Studio Code marketplace. And there are tens of thousands of extensions for all file editing needs. So we will search for pyFlies, and here it is. Just click on it. You have information about this extension, and just click on install, and that's it. The extension is enabled globally, so it is available. The next thing to do is to go to this Explorer tab and to the Hello folder and click on this icon, New File. We will call this file hello.pf. So pyFlies uses extension pf extension, and it is important to have that extension in your files. It is the way for Visual Studio Code to recognize this file as pyFlies. You will see this in the lower right corner. Okay, I will just increase this a little bit to be more visible. So pyFlies models are built with tests and screens, and you define the flow at the end. So we will start with this little Hello World test. So we just start typing test, and you will be offered with a code snippet that will expand the test. So just press tab, and you have a little layout of little tests. So you now have to type the name. I will just call it hello, and then press tab, and that leads you to this little condition table, which is represented as textual table. And here you specify variables for your trials. So in this case, we will use two variables. I will call them index and greeting. You notice how convenient it is to edit this table. I just pressing tab to move around the cells, and when I type something, it will auto format. So it will be very easy to build tables. I'll just quickly install Vim extension for Vim key binding, because I'm very used to this editor, and it will help me move around quicker. Okay, so what will be this index variable? In pyFlies you can specify the conditions by just typing the values for condition. For example, we can have index 1, and then we can have something here, hello person, or just hello. And then for index 2 we can have something different. But a way we usually do with pyFlies is to use expressions. That's the way to represent condition table in a compact form, and that condition table is evaluated and expanded during compilation or during code generation. So in this case, if I want, for example, my condition table to have 10 rows, where index will go from 1 to 10, I can use range expression 1 to 10. So this expression 1 and double dot and another number is a range, and I will say just loop. So this is a looping expression which can be used in tables, and this looping expression say iterate through this range from 1 to 10 and create row for each number, And here this greeting can be, for example, this constant string, but let's make it more interesting. We'll say hello person, and then we can reference index variable from the index row. So this string will now depend on the index, and in each row it will be hello person 1, hello person 2, and so on. Okay. So next thing to do is to specify what will be done in each trial of your test. So for each condition, and we separate each trial in 3 phases. I will just show that quickly in the documentation of pyFlies. If you go to test definition and go here, trial phases, you can see a little diagram that depicts this separation. So each trial is separated on 3 phases: fix phase or fixation phase, execution phase, and this third phase is either error or correct, depending on whether the subject responded with expected response in this execution phase. This first fix and this third is optional. You only have to provide the execution phase, and the way you do this is to specify this condition on the left side of this expression with this pointing arrow. So this left side is actually a Boolean expression that will be evaluated during compilation, and if it's true, then these components on the right side will be used in that trial. So for example, this line states that in fixation phase we will show the cross to the subject. And this left side is actually a Boolean expression where this fix is just a Boolean variable that will be true during the fixation phase. So we can say something like fix and index is greater than 5 to say show cross only in fixation phases where index is 6 to 10. Okay, so it's very flexible. We won't use fixation phase in this little hello world experiment, so we will just use this execution, and we won't make this execution phase any more complex, so just we'll say exec. It means do this right side for each execution phase of each trial. And we have many components in pyFlies. Here is the documentation of each component, and basically this documentation is represented in the same way these components are specified in the pyFlies source code. This little language for describing components is currently used internally to define components, but eventually it will be exposed to the user, so you would be able to define your own components. And this is very readable form where you have the name of the component, if it extends something, then the documentation of component, and then parameters for each component, their types and their default values, and the explanation what that parameter do. So for this hello world, we will use the text component. Text component has a content parameter, but you don't have to remember that for each component. You just start typing text, and you will have a little snippet that if you press tab, you will be offered to fill in the usual parameter that are filled in for that component. For this, it is content, and here I will reference the greeting from the condition table. So I'll say just greeting, and for duration, this will be the integer here. So each component can have specified duration, how long it will be displayed to the subject. And for example, we can make absolute value here of, let's say, 200 milliseconds. So every duration in pyFlies is given in milliseconds. Okay, so we have now hello. Let's complete it quickly. We need flow, but let's create a screen first. Let's say we have a screen intro. Screens are just convenient way to specify messages to the subject. They're just plain text where we can say welcome, thanks for running this little hello world example. So the screens are just plain text, but they're very powerful because I'll show you that in some of the future tutorials. They're actually piped through the templating engine and can be very flexible. You can interpolate variables, you can do loops, and so on. But for this little hello world, this is enough. And at the end, we specify the flow. Flow defines the order of tests and screens. So by default, we'll just say intro, show intro, and execute hello. Okay. Now we have our little hello world. And now let's try to generate something from this little description. I'll just run the terminal session here. It is nicely integrated into Visual Studio Code. In a future version of this extension, probably we will provide a way to just run generators from like content menu, right click or something like that. In this version, you need to run it from the command line, and it's anyway nice to see how everything is installed and run from command line. It's good to know. So let's just start with first thing to do. This pyFlies language is implemented in Python, and when you're working with Python, the good thing to do is to isolate your libraries for each given project. The standard way to do that in Python is to use Python virtual environments. So I'll show you how to do that. You run Python, and you specify -m, meaning run this module. And venv is a built-in module of Python that provides a way to create those virtual environments. And then just give it the name of the folder you want this virtual environment to reside into. So this command will create a virtual environment folder. You can see that here. And in this folder, you have the Python executable, and all the libraries you install will be there, but you have to activate that environment. You do that by running source venv. This is syntax used in Linux. So you source this activate script, and you can see that you're in this environment by this here. The syntax on other operating system might be a little bit different. So I will now see with pip. Pip is a Python package manager. I will see what is in this virtual environment by running pip list. And initially we see there is only pip itself and setup tools. That is the bare minimum for each virtual environment. And now let's install pyFlies compiler. We will install pyFlies scipy. Scipy, so will be the target of this compiling. And since this pyFlies scipy project depends on pyFlies, it will pull in the pyFlies language description and all the needed dependencies. Okay, that's it. We now have our compiler installed. We can see in our virtual environment that we now have pyFlies, which represent the language itself, and we have pyFlies scipy, which is a compiler for scipy. So it's a code generator that will generate a scipy script out of our description. And this language is built around a library called Textix. It's a library which is very convenient for building domain-specific languages and code generators. So we use textx command to list what is available to us. So we can list generators, and let's see what generator do we have now. So there are 6 of them, but what we are interested in are those 3. Those 3 are generators from pyFlies models to scipy, CSV, comma separated value, and log file. These 2 are provided by pyFlies project itself, and this scipy code generator is provided by project pyFlies scipy. So it's very nicely modularized. The architecture is based on principle of extensibility, and you can build another generator by creating a new project that will be installable with pip, and that can be visible then to textx generators. So let's start first by generating CSV code, or to be precise, CSV data file. So I say text x generate, the command is generate to generate something, and then I will say hello pf, and then I will say overwrite because I don't want to delete manually target file each time I run it, because by default text will not overwrite file if it's already exists, and my target will be CSV file. And you can see the CSV file is created. The nice thing with this integrated terminal is that these links to files are actually clickable. If you go with control click, you can open the file or you can open it from the Explorer. And you can see this condition file is rendered. So this CSV file actually represents the expanded table, condition table. And you can see how it's expanded from 1 to 10. And we have string hello person 1, 2, 3 and till 10. Okay. The next thing that is very convenient during developing of your experiment is to use log generator. Log generator will generate this pf log file, which contains detailed information about your experiment. So it represents all the components, all the default values of each component, and then the flow of your whole experiment. And it's nicely indented, so you can use default Visual Studio Code folding. For example, I can fold everything. I'll just give you a quick hint. If you want to run some command, you can try to search it in the menus, but many commands are not available in the menus. Many are available, for example, with just key binding. So just press Ctrl, Shift, and P, and you will see this search box where you can type the command. For example, fold all. You can see that is the fold all command, and this is the key binding for it. So just search by name. So we can see this flow, and we can see each element of this flow. So we have first one screen displayed with this content, and then we have this test displayed with this condition table and these trials. So if we expand trial and choose any trial, we can see the condition variable in that trial and the all variable used, and then we can see phases, and we have only execute phase, and in that execute phase we have a textual component displayed at 0 milliseconds from the beginning of the phase with the content hello person 4, and position is 0, 0, meaning the center of the screen, size is 20, and the color is white, and the duration will be 200 milliseconds. So this log is very convenient to investigate your whole experiment. So let's get back to our experiment and let's generate CyclePy code. Okay, CyclePy code is generated into the script hello.py. If I open it, we can see it's Python code for CyclePy, and it says when it is generated, on which date and which time, and it warns you to not manually edit this file if you want to regenerate later again. Okay, so let's try to run this little experiment. Python, I'll just type Python hello.py, and now I can see that there is no module named numpy, because in this script numpy is used. It is a dependency of CyclePy, and in my virtual environment I don't have CyclePy installed. I don't have numpy, so I don't have CyclePy and all its dependencies. I could do pip install CyclePy into this environment, but I prefer to install it on the system level using my package manager, because it's a relatively large package and I want to use my system level version all the time. And the way to do this in Python is to instruct this virtual environment to use system level packages if package is not found in the environment. If you go to your virtual environment, open this pyvn configuration file, you will see this include system site packages, which is by default set to false. Just set it to true, save the file, and now you can try to run your experiment again. Okay, this is a standard dialog from CyclePy. This is the screen initially, and then if you press space, there are hello person displayed in a successive order very fast, because we provided the timing of only 200 milliseconds. And more or less that's it for this getting started tutorial. I hope you find this interesting, and I hope you will enjoy using pyFlies. If you do find this interesting, you can watch some of other tutorials where I will show you how to build some real examples, real experiments. So if you do watch those, see you there. Bye.